Hello everyone, welcome to this video. So in this video, we'll talk about decision tree classifier. See, decision tree classifier, again a supervised learning technique. Like we know already in machine learning, we have a supervised learning technique. So in ML, we have unsupervised, supervised, semi-supervised reinforcement learning. So in supervised learning, we have a regression problem and then classification problem. So in classification problem, we have different algorithm to work. One of them is decision tree. So in this video, let's talk about decision tree, how it works, and what is the method behind this, what is the math behind this. Let's talk about everything, and then we will try to implement decision tree using Python. So let me first show you one data. So here you can see me on this. So here you can see there is a data, like in that data there are different attributes like ID, age, income, student, credit rating, buy computer and all. Okay. Basically using this data, you need to build a model to predict whether this person is going to buy computer to predict the computer, and these are the features like ID, age, income, student and credit rating. Okay. So in decision tree, how it works basically, you need to build a flow graph, and using that graph you can predict whether this will happen, whether he is going to buy this computer or not. So let me show something to you. This is your flow chart, okay? And using this flow chart, like see someone, if someone has age less than zero point 0.5, I'm saying he is going to buy the computer because it's just predicting class yes. But if suppose his less is like age is greater than zero point 0.5, in that case I'm comparing whether he is a student or not. Then in that case I'm comparing something else, and like each node finally they are giving the decision whether he'll buy the computer or not, yes or no. Okay, so this we have to build using this data, right? So first of all, let's convert this string into the number. As you know already, if you want to treat any machine learning models, we need to convert these strings into the number. So for that, I'm just using very simple code, label encoder. So I try to implement label encoder on all these columns. So let me do this. One thing I want to show here, you can see this. Sorry, let me read this again. Here you can see this ID. So ID is just this already an integer, and there is no, here you can see this is just a unique value for each row, right? So there is no meaning for this particular feature, so we can drop it as well. So let me drop this. Now here you can see, so we have age, income, student, credit rating and buy computer. Suppose anyone, just let's verify first this data. Let's see, if age is less than point 0.5, he is always buying a computer, right? Here you can see he's always buying a computer. Okay, so if again let's go to the graph, and we are already saying if age is less than zero point 0.5, yes, he will buy the computer. So are you getting my point? Using this data, if we are able to build this flow chart, using this flow chart, we are able to say whether he is going to buy computer or not using the this flow chart, right? But how to build this flow chart? This is the actual question here. How we are able to build this flow chart? This is called decision tree architecture, and we'll try to build this architecture, right? Mathematically, how we are able to do this, I will going to explain. Don't worry. Now the question is, why he picked first age? Why he don't pick maybe credit rating or a student or income something? Why he first picked age? Right here you can see first we're picking age, then we are picking student. So this is the question: why you are picking first age, then student, not income, then something else? Why this is happening? No, we need to learn that, right? This we'll learn right now. So the aim is we have to build that architecture, that decision tree architecture. But how we will build this? Let's try to understand this. So basically, what will happen here? You have a data. So you have a data, and suppose this is feature 1, feature 2, feature 3, feature 4, and this is your target. So you have to build a tree architecture, and using those architecture, we need to say, like suppose this is this F1, there is condition whether it's go to F2 or F3. Then if it's F3, then again saying this is condition to going for F3, either yes. Then if this condition satisfy, yes or no. So the question is how to build this architecture from this data. So there are two method to do this. Let's talk about entropy based method, and another is Gini index. Both looks almost similar. So let's try to understand entropy. So the question is how you are selecting feature 1 first, then F3 or F4, how you are doing this. So basically, you know, we need to understand first entropy. So entropy just looks like this: probability log to probability. So you are calculating probability of, so see, so entropy is actually measure of impurity in the data, and then finally we'll calculate the information gain. Using the information gain, we are able to say which feature we'll select. So then what is information gain? This is the right question. So basically, information gain is a measure of effectiveness effectiveness of the attribute. Like basically, you have an attribute like feature 1, feature 2, feature 3. So you are going to select that feature which has the higher information gain. Why? Because information gain is a measure of effectiveness of the attribute. Okay. So if we'll get information gain highest for F2, so in that case we'll select F2 feature first, right? So how will we will do? Let me explain here. So information gain formula is entropy entropy of your whole data set minus data set divided by data entropy of data set. Basically, if you splitting the data, right? So you have to split the time. Don't worry about the formula. I will going to explain each line. So no problem into this. I'm going to break this formula one by one. Don't you worry. Right. So let's first talk about this. In this data, here you can see in this data, we have this target the spy computer. So if you want to information gain for any, maybe you're looking for age. So anyway, you first have to calculate this one. So here you can see we have the by computer. So if you're calculating information gain for by computer, you have two things here, 0 or 1. So you need to calculate this, like for 0 you can see this. So there is total 50 50 divided by 14. So just write there log 5 by 14. I'm using this entropy formula, this one. So this will be the log 2, then minus we have rest 1, so that will be 9 upon 14 log 2, 9 upon 14. If you calculate this, you'll get the entropy for this particular column. Now again you have to calculate entropy, because actually you are going to calculate information gain for age. Then after we'll calculate information gain for income. Then we'll calculate student credit rating. Suppose you want to calculate entropy for this age age. So now you can see for age there are different split, because age has three things. One is your, here you can see, if you see the data, here we have youth, then middle age, then senior. So if you want to calculate entropy for first youth, then middle age, then senior, and then we'll combine everything, right? So if you want to calculate for youth first, so entropy for youth, in that case you have to check how many youth is there. So 1 2 3 4 and 5, there is total 5 youth. In 5 out of 5, there are, you can see no, no, then no, then yes, then yes. So you have 5 youth, but 2 times yes and 3 times no. In similar way, you can calculate for middle age, then you can calculate for your senior. So you'll calculate all the three, like middle age and then senior, and then you combine this. Combine is very simple. You have just do the weighted of this. So total 5 by 14, youth. Then you'll put this value. Then you have 4 by 14. You'll put this value. Then you have 5 by 14, and you'll put this value. So this is basically your entropy for age. Now, if you want to calculate information gain for age, so you have to formula will be entropy for your data set minus entropy for split. So already we have did this weighted and all. So we'll calculate this already. We calculated this. So this and this is we calculated here. This one, not this one. Yeah, here you can see the final one, the for all data, and then we calculate it for age. So if we do this, I think finally you'll get 0.24 something. So I have this value because I did this in my notebook. Anyway, so actually I want to explain you the process, how we are doing this. We have different feature F1, F2, F3, F4. This is the target. First we are calculating the entropy of the target. Then we calculated entropy of the feature one. And then information gain will be basically entropy of the target minus entropy of the feature one. Why we are looking for information gain? Because I just explained information gain has actually the effectiveness of that particular attribute. So basically measure of the effectiveness. So using that we can take the decision. Which feature has the any feature can have the maximum information gain. We are going to select that one. Why this is? Because the if information gain is highest for a particular feature, it means it has the minimum entropy. Entropy is a measure of impurity, and information gain is a measure of effectiveness. So if it is highest, this is the lowest. That's why we are selecting that particular feature. So I write the code here. Don't you worry. Already, actually, we have the sklearn package to implement decision tree, but I just write a scratch code to make you understand. So let me run this code. So if you run this, you'll find information gain and entropy for all the feature. So here you can see I am getting for age 0.246 something. For income, I'm getting 0.029. For student, I'm getting 0.15. For credit rating, I'm getting 0.014. And these are the entropy. Okay. So here you can see I'm getting the highest information gain for age. That's why I will pick first age. Okay. So now you are able to understand why I am taking age as a first node. Now there is another question. Suppose you pick age as a first node. Okay. Now how you can split this? It's not a randomly you can say if age is greater than zero point 0.5, this will be the answer. Less than zero point 0.5, this will be the answer. How we are picking this? Again, this is a question, right? So similar way, like we'll first pick the age. Now we'll go in age value, try to pick the value, calculate the entropy information gain, then pick the next value, calculate the information gain, then split on the next value. So we started picking the value, splitting the data. Basically, splitting means suppose you are taking first value is 1. So it's saying if a is greater than 1 and a is less than 1. So your data will become like two things, right? And you're calculating the information gain for both. Similar we are doing for all. Whenever you are getting the highest information gain, you'll pick that value. So here is the important point. Sorry, here is the important point. What we are doing here, first using the information gain, we are trying to find which feature I am going to select. So if you have the four feature, then if I selected the feature one using information gain, now I have to select for splitting criteria. So I will calculate information gain on each point and then I will take decision which splitting criteria will have the maximum information gain. I will select that information criteria. So even you can see here, I just write for one. Actually, we selected the first node is age. So let me do one thing. Here you can see for age you are taking 0.226, basically zero point 0.5 in our package. So here I'm taking uh, criteria age 0.226. So if less than 0.226 are greater than 0.226. So this is basically the the way we are calculating the information gain and selecting which feature I'm going to select. Then we are calculating again information gain on all the feature and then we are doing this. Now how we'll select the next node, right? So once we calculated the age, we decided the splitting criteria. Now your data will converted into two data set. One when you have the entropy is less than zero point 0.5 and when your entropy has the greater than zero point 0.5. So let me explain here again. Suppose I am writing one criteria here in this data. I'm saying data age greater than zero point 0.5. As on less than zero point 0.5, you are already getting the result. So let's talk about less than greater than zero point 0.5. Now again, I will calculate the entropy for all the feature to select which feature is going to next on the node. Okay. So most of the time the age is not going to be in the next one. Maybe one of the all like from income, student and credit rating. So the similar way I will finding here a student has the maximum, the information gain. If a student has the maximum information gain, now we have the criteria less than zero point 0.5. So break it again. We'll break it again into two credit rating and so credit rating less than zero point 0.5, credit less yeah, this is the student. No? After student, sorry, we are breaking into the two path here. So basically, from after the student, you are not able to reach to final one. Okay, that's why again there is two nodes here. Again, you have to split the data. Again, you calculate the entropy, sorry, information gain. We are selecting the nodes, and then we are reaching to final one. So the overall story is we are just calculating the information gain on each point. First, we are calculating for feature one. Then we are taking the split. Now on the rest data, again we are calculating the entropy, selecting the next feature, selecting the next feature. Then again we are using the entropy, splitting this. Then again selecting the next feature, and in this way we are able to create our decision tree architecture. How we will implement this in machine learning? It is very simple. See, let me go there. Let me read this data again. So I'm reading this data. Then I'm just encoding this data and dropping ID from here. So let me copy this code and okay. So I'm doing everything here again. Let me show the data. Here you can see this is okay. Let me make it to X and Y as you know. So Y is like the target by computer and I'm dropping from the feature. Then I'm just splitting the data, train tests using the decision tree classifier. Criteria is entropy. I just explained how entropy works. Let's fit the model and see the accuracy we are getting 100%. This is the problem of decision tree actually. Whenever you tree a decision tree, model. See here, you can see this is our decision tree architecture after training the model. But what is the biggest problem here in decision tree? Whenever you train the model, it will overfit. This is a biggest challenge. So now we have to actually avoid the overfitting. So whenever your model overfit, we need to do some penalty. So here you can see this is the def in the decision tree, feature in the decision tree. So let's try to understand how can we penalize our decision. So in the next video, I will again explain how to, uh, how to penalize our model, how make our like decision tree better model, right? So in the next video, I will try to explain that. Okay. Thank you so much.